Crime is everywhere, literally right outside your doorstep. The most common headline you see on Dateline News these days is probably a crime happening in your neighborhood. Why is this happening so much, and what is being done to prevent any reoccurrence of this crime? Things like neighborhood watches, increased police control, and increased non-tolerance for breaking the law have been incorporated. But is this enough? I mean, I think people still feel kind of unsafe walking around in their own neighborhood. There's a new prevalence in the field of neurocriminology that can further help reduce crime. Neurocriminology is a branch of crime that uses neuroscience to study correlations with defects in the brain and criminal behavior. Even though neurocriminology is limited in its research, neuroscience is advantageous in providing useful techniques to detect if one is predispositioned to cause crime. It does this by using innovative technology to pinpoint abnormal areas in the brain to deduce delinquent behavior. In the early 18th century, physicians attempted to use phrenology, which is the study of analyzing the shape of the skull bones to make significant scientific inferences about the size and function of the underlying brain areas. This technique was developed by Franz Joseph of Germany. Other techniques used like this were to assess how a patient walked, or monitoring their gestures, or weighing their brains to observe deviant behavior relationships. Soon, advancements in neurotechnology replaced these methods. In 1848, a landmark case involving the famous Phineas Gage was published, and people became aware that brain damage could have long-term effects on behavior dimensions. In 1848, Gage was working on a railroad construction when an explosion caused an iron rod to drive completely through his head. Before the accident, he was a normal, hard-working, reliable man, and after this accident, he was impulsive, he fought, he stole, lacked emotion, and couldn't keep a job. Even though the exact causation of Gage's injury could not be studied due to lack of technology back then, the observation was made of his behavior pre- and post-injury. The main areas under study in neuroscience research are the prefrontal cortex and the amygdala, because these are the areas of the brain that, when abnormal, are suggested to cause criminal actions. The prefrontal cortex is a portion of the frontal lobe of the brain that sits in front of your head, behind your forehead bone. This region of the brain is responsible for controlling impulse, rational reasoning, and social behavior. The amygdala is located deep within the temporal lobe of the brain that sits behind the temporal bone on the lateral sides of your head. The amygdala is part of the limbic system, and its function plays a significant role in emotional processing. The amygdala and the prefrontal cortex communicate with each other through association tracts between each lobe. They work together when faced with threatening situations to decide what actions needed to be taken. The studies of neurocriminology provide evidence through brain scans that abnormalities in the brain correlate with criminal behavior. Brain scans that show a non-adequately functioning prefrontal cortex and a small amygdala are common traits of convicted criminals. Brain scan machines used to produce these neuroimages are MRIs, CAT scans, SPECT scans, and PET scans. In many studies using PET scans, SPECT scans, and MRIs observed criminals, and they all observed reduced blood flow to the prefrontal and temporal areas of these criminals' brains. They also observed less activity in the amygdala. A common occurrence noted in these brain scan studies is that most of the convicted criminals have an antisocial, mental, or conduct disorder and or have a history of drug and alcohol abuse. In a study monitoring the likelihood of convicted criminals to repeat crime again, a cohort of 335 male offenders were observed over a 20-year period. It was shown that 50% of these criminals were more likely to cause crime again. Treatment of these mental disorders, drug rehab, or therapy to overcome conduct disorders are shown to be effective through many research experiments. Lithium and serotonin reuptake inhibitors have effectively treated anger and aggression. Nutrition, or lack thereof nutrition, can also affect anger. Omega-3 fatty acids, amongst other nutrients, are important components of the nervous system and are found to be deficient in the diet. When essential fatty acids were administered to men in prison, violence was reduced by a third. In another example, similarly, the brains of pedophilic offenders show structural deviations from normal in the right amygdala of their brain. Particular attention was devoted to the case of a father who suddenly became pedophilic and was imprisoned, who later turned out to have a brain tumor on his right frontal lobe. Removal of the brain tumor resulted in re-insulation of his brain and non-pedophilic personality. Other risk factors that causes an increased propensity for an individual to cause crime are genetics and the environment. Lead pollution in the air has been shown to demonstrate that prefrontal cortex development is harmed by the lead in the air. Genetic contribution to violent behavior can be used to reason such behavior 40 to 60% of the time. Twins are commonly used to assess genetically influenced behavior. Biological twins share all of their genes, and fraternal twins share 50% of their genes. In a study investigating genetic contribution to antisocial behavior, it was shown that genetic behavior is strongly inheritable by 75%. Specific to molecular genetics, a deficiency in the gene that codes for MAO, an enzyme found in all humans, but this defect in males of this enzyme could exhibit a male to exhibit aggression, rape, and arson. This X-linked inheritable gene is more likely to affect males. Having MAO deficiency in combination with childhood maltreatment is a strong indicator of developing a conduct disorder. When looking at prenatal nurturing, a study was observed following 1,000 pregnant women. These women who ate less seafood or did not take omega-3 fatty acids had offspring that demonstrated lower scores in their neurological development. They also had antisocial behavior, and in uncovering the biological leads, the evidence provided thus far have supported that neuroscience can have potential leads in determining criminal predisposition. With the contribution of these findings incorporated into the legal system, it may one day affect legal decision-making to help decrease crime rates. Even with all the research, neuroscience has failed to make it into the courtroom. But why? Most people are unsure about neurocriminology because of its lack of research. But neuroscience is also considered to be persuasive and therefore can affect legal decision-making. The influence of neuroscience evidence in legal decision-making was explored in an experiment involving 294 participants. The participants were randomly assigned to groups in which one group got evidence that included neuroscience and the other group did not. And then they were asked to make legal decisions about a criminal case. The visual neuroscience evidence was determined to be more reliable and accurate, but did not affect the legal decision. Though it is true that both studies demonstrated that neuroscience evidence is found to be more reliable and accurate, the later study pointed out that it did not affect legal decision-making. The legal system is generally conservative and relies on traditions. The only science-based objective data allowed in the courtroom is DNA. What the evidence presented in this video has sought to do is clarify how biological and environmental aspects of the self can be used to understand, identify, and hopefully predict how individuals or who can criminally offend. Understanding these processes is the first step and then being able to modify these risk factors or target at-risk individuals for service designed to attenuate their criminal propensity. Though neuroscience provides reasons for criminal misactions, more research is necessary so its accuracy can be proven reliable enough to use in legal circumstances. It is expected that neuroscience will be used more frequently in court cases in the future.